Okay. Just in civil structures, the environmental implications of materials are absolutely massive. Aside from timber and glass, which is another big contributor to greenhouse gas, let's look at the top three. Cement manufacture worldwide is 8% of global greenhouse gas emissions involved in making building materials, just for cement, which is used in mortar. It's also used in making concrete. Cement, there's a large steel tube in a cement factory. You feed in calcium carbonate, limestone, silica, alumina, iron oxide, that's clay, finely ground. In the middle, at around about 700 degrees, the calcium carbonate turns into calcium oxide, which keeps on falling down, and the carbon dioxide just goes back out the back of the furnace. No way you can avoid that. If you want concrete, if you want cement, you need to do this. And out the bottom of a cement kiln comes all the materials. What's missing? There it's 2200 degrees C and it's coal-fired. Once again, more carbon dioxide. It makes 8% of the world's greenhouse gases. Steel makes 5%. Steel making makes 5% of the world's greenhouse gases. That's a blast furnace. You feed in calcium carbonate, silica, I've got calcium oxide, calcium carbonate, silica, iron oxide in the top, carbon in the form of coke, just straight, strong form of carbon so it doesn't crush and it leaves gaps for the air and the gases to come up. Then in here you're making carbon dioxide. I'll simplify the equation. In here you're making carbon monoxide. Up there it turns into dioxide. But carbon dioxide out the top, 5% of the world's CO2 is in steel making. Out the bottom, reason why I circled this earlier, notice how that's similar. One of the ways you can actually save a bit of greenhouse gas is to, what you can do, when this slag, you feed the calcium carbonate and the silica straight into the furnace so it soaks up all the rubbish out of the dirt, or the ore, let's use the technical phrase that's put in the top. It picks all the rubbish out of and it dissolves it. And then you're just left with iron, density of 7.8, and slag with a density of about 2.3 to 2.5 floating on top, like cream on top of milk. And if I water quench that straight out, I can add that to the cement mill. And I can save on greenhouse gas. That's one of the ways you can do is you can use steelworks slag as another cementitious material. The third one, aluminium production. I'm just checking my notes to make sure I was accurate. 2% of the world's greenhouse gas comes from making aluminium, the stuff they use in window frames. A straight carbon anode with a power plant worth of negative charges running into it. In a bath of molten cryolite, a sodium aluminate, that's molten. That's fluoride based as well. Could be somewhere or other there's an aluminium in it. I can't remember the exact one. It's cryolite cryolite is the name of the mineral. But basically, you have a molten bath at 700 degrees and you physically electroplate aluminium. To run an aluminium smelter, you need an electricity plant right next to it that needs that much electricity. 2% of the world's greenhouse gas come from extracting aluminium.